Okay, it is expected that you finish this review by the end of the period today along with the video. If you don't finish the video, then the most that you can get for the video is 70% of the grade. So let's start with ranking the electrostatic guns from the most to the least. So things to remember, because it's times 10 to the negative 9, all these numbers have the same value, so you don't have to worry about how many zeros to the left. What we need to worry about is which ones have the bigger number, because the negative is just the charge of the particle. Because of that, then we're only worried about these numbers. So negative 8s, the physics, P, C, okay, so we could just use the first letter. So physics is negative 8, which is equal to the FIS 23 to the OTS 3000, which are the greatest of the bunch, followed by 4, which is the Conard Plus, followed by the 2, which is the Thor 100, followed by the negative or NEG 3.0. We're talking about these particles because all these particles are negative. How do they interact? So these two particles being negative, they're going to come towards each other with those field lines, but they are not going to touch because they're the same charge, and we know that same charges repel. So arrows pointing in, arrows pointing in. That's one of the things you have to remember. Negative charges have the arrows pointing in. Same charges are going to repel. Same charge, repel. And negative charges points into. Big two things you have to memorize. You have to memorize these two. Now you're comparing. Compare the Conard Plus and the Thor 100. Here's the Conard Plus. Here's the Thor 100. One is a 2, one is a 4. So in this case, when it tells you how do they differ, how does the force differ, we have to say, or we can say that because it's a 4 and this is a 2, the Conard Plus is double of the Thor 100. You could also say that the Thor 100 is half of the Conard. You're saying the same thing. So Conard Plus is double of the Thor 100, or you could say that the Thor 100 or Thor 100 is half of Conard Plus. The other question here, number 4, is why do we have a spray that looks like this versus the regular spray that does not curve outward? Think about the curves here too. These curves are those electric field lines. So they are all the same charge. Don't forget that these are all the same charge. Same charges repel. So that's the science behind why the spray is going to look like this. This is actually taken from an online database. This is exactly what happens to those guns. We're not making this up. So because the paint guns all shoot out a negative charge, the negative paint particles repel each other. That's an E. So the takeaway is the fact that they're all the same charge, so they're all negatives, all the same charge. and they repel. Negative charges are going to repel. If they were all positive charges, they would also repel. So we have two employees. They're using two different electrostatic guns to paint the same room. However, one of them is going to give a positive charge and the other one is going to give a negative charge. What is going to happen to the paint? Because these charges are negative. Because charges are negative. And positive. They are opposite in charge, so the paint will attract each other. So what would I recommend to these employees to prevent this? Use a gun with the same charge. On this one, you're looking at figure 1. Figure 1 is up here. So let's look at figure 1. The question is, look at figure 1 and explain why electrostatic paint guns are an efficient way of painting a negative object. If you notice, if the electrostatic paint gun, once you're introducing to this negative charged object, now all of these positive charges are going to surround the object. So they're not just going to paint on one side of the surface. They're actually going to go around and paint all of the sides at one shot. Okay? So, because the charges are, in that case, positive, and the object is negative, the paint particles will attract to the negative object and surround it while it's painting, while it is painted. So because the charges are positive and the object is negative, the paint particles are going to attract the negative object and the object is going to be surrounded while it is painted. So that's why they're a very efficient way of painting. These guns actually cost somewhere between, I think it was like $1,000 for one of the cheaper ones. So no, not every of these things are easy to purchase. That's why some places don't even use them, but when they are invested on, they're very efficient when it comes to painting. Some people do use them for car paint, and it's supposed to be more even when it paints. So here we have all these positive charges on this nozzle. So this is a positive spray paint gun, electrostatic paint gun, and we have a neutral wall. And we're going to talk about what happens to the protons and the electrons. In this case, all of the electrons are going to come towards the positive charge because only the electrons move. Only electrons move. So then once they're migrated to this side, then all these positive charges are going to be exposed on the other side. And remember, this is called polarization. So what's going to happen with all the particles? You drew this, you have to make the drawing, and then explain that the object, the neutral object, will be polarized, and all of the electrons will be attracted to the positive paint and the protons, the protons or positive charges will be exposed on the right side. Mainly what I want you to be able to tell me here is that neutral object gets polarized because these negative charges are either going to move towards the nozzle or away from the nozzle. In this case, they're moving towards the nozzle because you have positive charges. If these were negative charges, then you would write all of the positive charges here, because all of the negative charges would be pushed away and they would end up on this side of the wall. Okay? Number 8, you don't have to do. Yay. But you have to make sure you can do these problems and then you can put them in the calculator. These problems are going to be the kinds that you have to actually write out, so make sure that you write these problems out. So 2 positive paint particles with this charge of 5.2 times 10 to the negative 9 are separated by 0.354 meters. What is the magnitude of the force between the charges? We're looking for the force. Sorry, K. K is a constant. Don't memorize K. I'm going to give you K. So 9 times 10 to the 9th. Not negative 9, positive 9. Okay? These are negative numbers. This one's going to be a positive number. I saw a lot of people putting 9 times 10 to the negative 9. This is a positive 9. The first charge is 5.2 times 10 to the negative 6. The second charge is also 5.2 times 10 to the negative 6. The distance between them is 0.354 meters. This is 1 point. You write this, I can give you plus 1 point on the, it may be 2 points, and then 2 points, and whatever. It's at least 1 point. So 1 point for this section. Writing the equation. So you're still doing gas, but I'm not making you write givens, unknowns, equations, substitute, solve. But you're still doing gas. You're always doing gas. Fe equals K Q1, Q2 all over D squared, because we did not give you another equation for this unit. Thank goodness, because this is weird enough of an equation. So when you solve for F, for the force, 9 times 10 to the 9th, 5.2 times 10 to the negative 6, 5.2 times 10 to the negative 6, all over 0.354, and this is one thing the students keep missing. Your distance is squared. That's why I want you writing the equation before you substitute, so you don't forget and you can cross-reference everything. Distance is squared. All right, so I'm going to put it in the calculator at the same time as you should be. I'm going to do the top of the fraction first, and then I'm going to do the bottom of the fraction, just so I do every single one of the steps. 9E9. No negative, just the 9. Parentheses. These are both negative numbers. No, these are both positive numbers. So 5.2 e to the negative 6. Open parentheses, 5.2 times e to the negative 6. And then this is the top of the fraction. 0.24336 all over. Now I'm going to square. Don't forget to square. But if you do, show all your work, because then I can give you every single one of your points and then -1 for not squaring. So then it won't be as bad when you get points docked off. 0.24336 divided by 0.125316. And then that gives us 1.94 newtons. This is very close to 2. Very close. I'm just going to leave that here because we're going to talk about whether it doubles or triples when both double. So I'll come up with a way to easily check if we're close to the number. So is a force repulsive or attractive? Two positive charges, same charge. Same charges will repel. Explain your answer. Same charges will repel. Opposite charges will attract. Same charges will repel. So here it says that we're close to 2. So 1.94, we're close to 2. So what is the new force if both of the particles were to double? There's two ways of doing this. Instead of just doubling this twice, you can say, well, let me put this as 5.2. Let me put this as double of 5.2, which is then 10.4. So you can write it 10.4 times 10 to the negative 6 for both and then figure it out that way. That's one way to do it. If you want to be simple, you could say that this is almost 2, so this is 1.94, and the two particles are doubling. So because this Q and this Q double, so that's double and double again. In this case, they're actually quadrupling. So if they're quadrupling, what is 2 quadrupled? So what's 2 doubled is 4, and then another 2 is 8. So this force would be 8 newtons, or about 8 newtons. 1.94 times 4, 7.76 if we want to be exact. If you give me an explanation of how these numbers are close enough to your 8 and why you got to that number, okay, that would work for me. So this is the answer because the two charges are doubling. So the force would quadruple. If only one of these, if it said 1, then it would only be double. So it would only be double this number or 4 times. Okay? If it was only 1 charge, then we would only double, aka 4 newtons, or 1.94 times 2, which is 3.88 newtons. Okay, so that's all that it has to do with the charges. And let's finalize with magnets. What metals can magnets attract? Only iron, nickel, and cobalt. These magnets are only going to attract these 3 metals because these are the 3 metals whose electrons are going to rotate in the same direction. Okay, these electrons on the outer shell can magnetize. Okay, so some metals, like Fe, let me just iron, nickel, and cobalt will allow electrons to spin in the same direction. Not aluminum though, right? So aluminum will not have the iron spinning in the same direction, the electron spinning in the same direction. Explain why iron, nickel, I spelled nickel wrong here, and cobalt can become magnetic? Because electrons on the outer shell will spin in the same direction. Okay, and then we draw the magnetic field, the lines from the north to the south, looking like this, and then spreading out further and further away, always coming back to the poles where there's more lines. And we said that if there's more lines equals a stronger field. Those things you have to memorize. Stronger field. And then the arrows always point from the north to the south, just like from the positive to the negative. And then when you draw these, same charges will repel, so they're going to look like this. And because they're negative, the arrows are going to point towards. So coming towards, but then pushing, and then the arrows point, oop, this one's in the wrong direction, sorry, towards the south. So same, looks the same as this one. The lines come towards the the magnet, but then they end up pushing away. So then the north points out of this, the arrows point out. Okay. And then for north and south, they actually end up attracting. So they're going to look like this, but then the arrows go from the north to the south. Make sure that the arrows are drawn correctly, the pictures are drawn correctly, and that the arrows point in the same direction, because that's where you're going to get your points from. So the direction of the arrows is where you get points. Direction of arrows. And that you have the right attraction or repulsion. Arrows drawn correctly. Or lines drawn correctly. And then we have two magnets with the domains. These are unaligned. These ones are aligned. So which one of these is the magnet? This one's magnetic. So the first is magnetic because all of the domains are pointing in the same direction. That also means that the electrons are spinning in the same direction. Go over this a couple times. If you want another copy of this, what I recommend is that you do it again as if it's the test. If you want to study at home, I'll leave extra copies for the sub, and she can or he can give you an extra copy if you wish. So just in case, I'll leave a few extra copies, and then you could practice this as a test, or you could just read it over and over and review it. There's very few things that you need to make sure that you memorize. But if you can get through this, you can get through the test. You'll be doing great. I'll see you on Tuesday. I'm at a district meeting today.